Welcome to the final chapter of our journey into data for AI. By now you should have a solid grasp of the fundamentals. In this video we'll recap the key concepts, ensuring you're ready to apply what you've learned. Let's start by understanding why data is so crucial in AI development. High quality and sufficient data are the backbone of any successful AI project. Without the right data, even the most advanced algorithms won't deliver the results you expect. So let's dive deeper into what data really means in the context of AI. You might be wondering, what exactly is data? According to the Indonesian dictionary, data is factual information that can be processed by computers, such as text, numbers, graphics, or sound. The Cambridge Dictionary adds that data is information, especially facts or numbers, collected for analysis and decision-making. Experts like Tata Sudabri describe data as raw facts that need further processing to become meaningful information. In short, data is the foundation for all AI systems, and understanding its definition is the first step. Manage information efficiently. It's important to distinguish between datasets, and databases. Data refers to individual facts, which can be text, numbers, images, or sounds. A dataset is a structured collection of data, often used for machine learning, statistical analysis, or visualization. Meanwhile, a database is an organized system for storing multiple datasets, making it easy to retrieve and manage information for different applications. Understanding these differences helps prevent confusion and errors in AI development. Let's look at a visual example to clarify the difference between data and a dataset. Imagine a table where each row represents a customer. Each individual row is a single data entry, while the entire table is the dataset. This structure allows us to analyze trends and patterns, which is essential for AI tasks like machine learning. By understanding this, you'll be better equipped to organize and utilize your data effectively. Databases take things a step further by organizing multiple datasets in a structured way. Think of a database as a collection of tables, each storing different types of information. This organization makes it easy to access, update, and manage large amounts of data. Databases can store various data types, including text, numbers, and images, making them versatile tools for AI projects. The relationship between datasets and databases is key to efficient data management. Dataset is typically a single table or a structured collection of data extracted from a database. In contrast, a database can contain many datasets, each serving different purposes. For example, a company's database might include customer data, sales records, and inventory lists, each as separate datasets. Recognizing this distinction helps you select the right data for your AI models and ensures you're working with accurate information. Just like people have different personalities, data comes in various types, each suited for specific AI tasks. The main categories are structured and unstructured data. Structured data is organized in a fixed format, making it easy for computers to read and analyze. Unstructured data, on the other hand, lacks a clear structure and can be more challenging to process. Let's explore these types in detail to see how they impact AI development. Structured data is highly organized, often found in tables with rows and columns. This format makes it easy to process and analyze, whether by humans or computers. Examples include spreadsheets, databases, and CSV files. Structured data is essential for tasks like statistical analysis and machine learning, where consistency and clarity are crucial. It's the backbone of most traditional AI systems. Quantitative data is all about numbers. It measures quantities like height, weight, temperature, or age. This type of data is crucial for AI models that require precise measurable inputs. Quantitative data can be further divided into continuous and discrete types, each with its own characteristics and use cases. Let's break down these subtypes to understand their roles in AI. Continuous data can take any value within a range, such as decimals or whole numbers. Think of measurements like temperature, time, or weight. For instance, if you own a store, you might track the temperature throughout the day to decide when to turn on the air conditioning. This helps create a comfortable environment for customers, showing how continuous data supports practical decisions. Discrete data consists of countable values, usually whole numbers. For example, the number of products in stock at your store is discrete data. You can't have half a product, so these values are always integers. Discrete data is often used to track inventory, count events, or measure items that can't be divided further. It's a key component in many business and AI applications. Categorical data is information grouped by labels or names rather than numbers. This type of data helps classify items based on characteristics such as gender, product type, or color. Categorical data is essential for organizing and analyzing information that can't be measured numerically. It's further divided into ordinal and nominal data, each serving different purposes in AI. Ordinal data is a type of categorical data with a clear order or ranking. For example, customer ratings for a class like 4.86 and 4.83 can be ranked to show which class is better. This ordering helps AI systems prioritize or sort information based on quality or preference. Ordinal data is widely used in surveys, ratings, and any scenario where ranking matters. Nominal data is categorical data without any inherent order. For instance, gender, male or female, is a nominal category. These categories can be labeled and grouped, but there's no ranking between them. Nominal data is useful for classification tasks in AI, where the goal is to sort items into distinct groups without comparing their value or order. Structured data doesn't fit neatly into tables or predefined formats. It includes things like text documents, images, audio, and video files. This type of data is more complex and harder to organize, but it's increasingly important for AI applications like natural language processing and image recognition. Handling unstructured data requires advanced techniques to extract meaningful information. You may have heard the phrase, garbage in, garbage out, or GIGO. This means that the quality of your AI's output depends entirely on the quality of the input data. If you feed your AI poor, irrelevant, or incorrect data, the results will be disappointing. That's why it's essential to ensure your data is accurate, relevant, and well organized before using it in any AI project. Let's look closer at the GIGO principle. In this context, garbage refers to data that is poor, irrelevant, or incorrect. If such data is used, the AI system will produce unreliable or flawed results. This highlights the importance of careful data collection and validation. Always remember, the quality of your AI is only as good as the data you provide. Data problems often arise from mistakes during collection or recording, or from unreliable sources. Common issues include irrelevant data, outliers, duplicates, missing values, and incorrect entries. These problems can significantly affect the performance of your AI models. Identifying and addressing these issues early is crucial for building reliable AI systems. Missing data is one of the most common challenges in data preparation. There are several ways to handle it. You can remove rows with missing values or fill them in with the average or median if the data is numerical. Choosing the right approach depends on the context and the impact on your analysis. Proper handling of missing data ensures your AI models remain accurate and robust. Strong data infrastructure is essential for managing, processing, and analyzing data in any organization. It centralizes data storage, making information more secure and easier to manage. With the right infrastructure, companies can handle large volumes of data, perform complex analyses, and make better decisions based on accurate information. Effective data management means storing information in a centralized, secure location. This makes it easier for organizations to protect sensitive data and ensure it's accessible when needed. Good data management is the foundation for all other data-related activities, from processing to analysis. Data processing involves using computational resources to analyze and model large datasets. This step is crucial for extracting insights and building AI models that can solve real-world problems. With robust processing capabilities, organizations can handle complex tasks and make data-driven decisions efficiently. Data integration brings together information from various sources, creating a unified view for analysis. This is especially important in industries where data comes from multiple departments or systems. Integration ensures consistency and completeness, making it easier to draw meaningful conclusions and build effective AI solutions. Protecting sensitive data is a top priority for any organization. A good data infrastructure includes security features and protocols to prevent unauthorized access, theft, or misuse. This not only safeguards the organization's information but also ensures compliance with regulations and best practices for privacy and security.